Hey, let's continue conic sections. We've talked about parabolas, we've talked about ellipses, and this is our last conic section, and we are now going to look at hyperbolas. Say it with me, hyperbola, ricola. All right, hyperbolas. Hyperbolas may be related, I'm sure, somehow to hyperbole that you probably talked about in English class when you over-exaggerate something. Maybe because if you remember our drawing from conic sections, a hyperbola is exaggerated in its length or the way that it cuts the cone. I'm not sure, but I'm sure they're related. And here's some places you might see the shape of a parabola, the shape that a shadow takes on a wall from a lampshade. That right there is a hyperbolic shape, just places you might run into. In basketball, the way the panels come together. And interestingly enough, in supersonic jets, when their sonic boom hits the Earth, the shape that it takes when it intersects the Earth is a hyperbolic pattern, which is really useful to those aeronautics guys who are trying to figure out how the sonic booms maybe interact with the environment. This is a great chance to look back at the shapes we've looked at so far. If you remember parabolas, we had two different equations. We had x squared equals 4py, and we had y squared equals 4px. And parabolas are really a special shape in conics. They don't have a square term on it for both x and y. Only one is squared. And you notice it's the section, the plane is parallel to the outside of that cone that it cuts. Then we had circles and ellipses. Circles we looked at already. A circle has the equation x squared plus y squared equals r squared, which is very similar to the equation for an ellipse. So an ellipse is x squared over a squared plus y squared over b squared equals 1, and it always equals 1. And depending on a or b, if a is bigger or b is bigger, it will either be elongated along the y or the x-axis. It'll be horizontal or vertical. Well, when we come to hyperbolas, you'll notice that it's very similar to what we see in circles and ellipses. So the equation for a hyperbola, you'll notice very, very similar here. This should be familiar. It's x squared over a squared minus y squared over b squared equals 1. So it's the same as the ellipse in every way except we're subtracting the two pieces. Now in this case, when our x squared term comes first, this will be a hyperbola that will have the following shape right here. Here's our axes. It's x squared, so since x moves left to right, we can remember it that way. The graph of this hyperbola will be left to right. Now, hyperbolas also have asymptotes involved with them, and we'll figure out those in a second, but the graph of the hyperbola will approach those asymptotes on both sides, onto infinity. Now they still have vertices, as before, and now the foci, instead of being inside, well, they're still inside each piece, but they're not between the two vertices. The foci are now further out than the vertices. So what I'm highlighting right there in red, you can kind of see inside each shape of each cup kind of the hyperbola, that's where the foci will be. Well, we can also do these vertically. So let's look at, what if we did the y piece first? Y squared over b squared minus x squared over a squared, and that equals 1. Well, this will be the case where we'll now have a vertical hyperbola. So we'll move that up a little bit, and actually I'll just move this whole piece down, make it a little easier to look at. All right, so this piece, if here's our axes right here, this hyperbola would open up or down, and that's easy to remember because the y-axis runs up and down, y up and down, and just as before, we will have asymptotes that the graph will hug, those asymptotes. We'll have vertices right here, the top and bottom of each piece of the hyperbola, and then the foci will be further out than the vertices. They will be inside the bowl of each hyperbola. So that's how the equation relates to the equation of an ellipse and a circle, and somewhat to a parabola. Very similar, just different in that we have subtraction. So there's an intro to the equation. Check back for some examples.